I am Leo Wang, and today we're exploring a concept that's rapidly gaining traction in the AI community, context engineering. While some might see it as a new buzzword for an old idea, it represents a crucial evolution from what we commonly know as prompt engineering. The core idea is that as AI models become more powerful, the focus shifts from writing a single perfect instruction to architecting a dynamic system. This system's job is to continuously provide the AI with precisely the right information in the right format at the right time to solve a given task. It's about creating an environment where the task is plausibly solvable by the model. Unlike static prompt engineering, context engineering is about managing a flow of information, dynamically populating and changing the context based on the evolving needs of an AI agent. To truly grasp its importance, we need to understand the common failures that occur within an AI's context window. The first is context poisoning. This happens when a small error or hallucination enters the AI's working memory and gets repeatedly referenced, leading the entire system astray. For instance, if an agent hallucinates a minor detail about its goal, that false information can propagate, causing the agent to pursue an irrational objective. The second issue is context distraction. As the context window fills with information, especially from a long conversation or a history of repeated actions, the model can get distracted. It may start focusing on repeating past actions rather than generating novel solutions to the problem at hand. Research indicates that model correctness can begin to fall significantly as the context grows, with some open-weight models showing degradation after as few as 32,000 tokens. Then there's context confusion, which occurs when superfluous content, like irrelevant tool descriptions, is included in the context. Studies show that providing an AI with too many tools, or tools that aren't relevant to the user's request, can cause it to generate low-quality responses or call functions unnecessarily. This is particularly problematic for smaller models. Finally, we have context clash, a more severe version of confusion, where new information directly conflicts with existing data in the prompt. This can dramatically degrade performance, with some analyses showing an average performance drop of nearly 40% when context is provided in conflicting, piecemeal turns instead of all at once. So, how do we solve these problems? This is where context engineering strategies come into play. The first is a familiar one, Retrieval Augmented Generation, or RAG. This involves selectively retrieving and adding only the most relevant information to the prompt. For an agent with access to dozens of tools, RAG can be used to select a small, relevant subset for the task at hand, dramatically improving focus and performance. Another strategy is context quarantine, which involves isolating context into dedicated threads for specialized agents, preventing cross-contamination of information in a multi-agent system. Context pruning is the act of actively removing irrelevant or unneeded information. Think of it as a re-ranking system that filters a large amount of retrieved data down to the most essential pieces before feeding it to the AI. We also have context summarization, which condenses long conversations or large documents to preserve the most critical information while freeing up space in the context window. This is essential for maintaining long-running interactions without succumbing to distraction. Lastly, context offloading involves using external systems, like a database or a dedicated tool, to store and manage information, creating a form of short-term and long-term memory for the AI that exists outside its immediate context window. Ultimately, context engineering is about recognizing that a large context window isn't a magic bullet. It's a resource that must be actively and intelligently managed. This shift from static prompts to dynamic context management is a sign of the field maturing, paving the way for more robust, reliable, and truly intelligent AI systems.